This is page 486, number 28, because that one might be a little bit funky. All right, so you got 10 to the 1 over x power divided by x squared dx. So again, we've got a variable with an exponent in it. So this is where we substitute. So we call that e to the natural log of 10. And then you'll end up multiplying that times your exponent, which is 1 over x. And all that is going to be over x squared. So I do want to do a little bit of cleanup here in the next step. And I'm going to do this e to the natural log of 10 times, instead of 1 over x, we're going to call that x to the negative 1/2 power there, over x squared dx. Okay, so as we mentioned before, we have our e expression, and then we have this extra little exponent right here. And so whenever that happens, we have to do u substitution. Sorry, I had to pause the video. Now I'm back. I don't know if I was in the middle of saying something or not. But whenever we have that extra variable, that's when off to the side you got to do the u substitution. And you're always going to take the exponent for e times x to the negative 1/2 power. And that's what you're going to call u. Okay? So now I'm ready to take the derivative of u, which means I got to bring that, take that exponent, bring it forward. So I end up with negative 1. So I don't really need the negative, right? I mean, what's going on? So it's just negative 1 times that, which is really just negative. So we're going to have negative natural log of 10. Always subtract 1 from your exponent, which is going to give me x to the negative 2. That's my derivative. Okay, so now let's look at what we have here when we substitute back in. Okay, so I know I have e to the u power, and then I have this 1 over x squared over here that I have to deal with. Well, again, I have x to the negative 2. That means 1 over x squared. So I need to isolate that so that I know how to substitute. So I'm going to have to get rid of this negative natural log of 10 thing. So divide both sides by negative natural log of 10. And that's, so those cancel. Whoop, whoop, whoop. So now I know what to substitute here. So for x to the negative 2 power, which is what I have over here, x to the negative 2 is the same thing as 1 over x squared. So I have substitute times 1 over negative natural log of 10. And then that little du thing. Okay? Well, the 1 over negative natural log of 10, that's a coefficient. So I can bring that whole thing out. I'm going to move the negative on top because that's just normal looking. So that's outside my little radicand there. Not radicand, my integral. And I have just e to the u du left. So the derivative, antiderivative of that is just e to the u. Put everything back together. So it's negative e to the u over the natural log of 10. And now instead of u, I have to put the definition of u, which was, let's see, I had negative, and it's negative now, e to the, so instead of u is natural log of 10 times x to the negative 1 power over natural log of 10. And then your last bit of cleanup, this e to the natural log of 10, remember that's how you started. That used to be the number 10, so you have to make it number 10 again. So it's negative 10 to the x to the negative 1 power over the natural log of 10. The only other thing they might do, instead of writing it x to the negative 1 power, let's see, I'm going to scoot over here. Your book might go ahead and put that back. X to the negative 1 power is 1 over x. In fact, that's probably the best thing to do because they gave it to you like that over the natural log of 10. And don't forget your plus c. All right, so that's number 28.